Welcome back. Today we are going to see one interesting problem to solve Fourier sine transform. So here the problem is find the Fourier sine transform, that is fs e to the power minus x. So we have to find the solution or solve this problem. So before solving, we need to know or we need to understand the problem. So here we have to find fs e to the power minus x. So the function is what? F of x will be e to the power minus x, clear? But what is the domain? Because that is very much important to apply the limits. So if domain is not given, then we can write x belongs to 0 to infinity. That means x belongs to positive real line. Okay. Now what to do? We need to solve this problem. So before solving the problem, we need the formula fs. So fs is what? Square root of 2 by pi times 0 to infinity f of x sine wx dx. So this formula, if you don't understand how this formula came, then you can refer the lecture 1 of the Fourier transform playlist. You will get the idea that how the formula came. It will be very clear to you then. So f of s is this. Now what to do here? We have to apply this f of s. So if we apply, what happens? It will be square root of 2 by into integration from 0 to infinity, because s is 0 to infinity, domain is 0 to infinity. F of x is what? E to the power minus x, then sine wx dx. So when you have e to the power something, exponential and sine, exponential and sine, or exponential any trigonometric function, okay, how to find the integral? So there is a formula, okay, that you can use. So the formula is what? That we have to see. So for indefinite integral, it will be e to the power ax sine bx dx if I write, okay, then it will be e to the power ax by a square plus b square whole into what? A sine bx minus b cos bx. So this is the formula. How this formula get? So if you take this one function, this another function, okay, then apply the integration by part formula and derive, you will get this formula. So this formula we have to use here. So now how to use here this formula we have to see. So as it is indefinite, so there will be some constant, but in our problem we are solving and it involves what? Some limits, so there will be no c term. But here one thing you have to see, you have to compare this thing. If we compare, here you can see that a will be minus 1 and sine bx, b will be w. So we will apply this formula now. If we apply, then what will happen? First factor will be same, square root of 2 by pi, then inside the formula will change. So what will happen? E to the power minus x. So e to the power minus x by a square plus b square. So 1 plus w square whole into what? A sine bx. A is minus 1, so minus sine wx, then minus b cos bx. So w cos wx. So this will be the form. Then close the bracket, put the limit 0 to infinity. Now here we have to see carefully when we apply the limits. So here, so e to the power minus infinity means in place of x, if I write infinity, then what will happen? E to the power minus infinity will be 0. So 0 into some factor or any factor will be 0. So inside will start and it will be 0. Then minus of e to the power 0, because this second limit, lower limit you have to apply. So e to the power minus 0, okay, divided by 1 plus w square. So e to the minus 0 means e to the power 0, that will be 1. So 1 by 1 plus w square, but inside what will happen? Minus sine wx. So minus sine w into 0. So it will be sine 0. So total will be sine 0 means sine 0 value is 0. So 0 will write. Next minus w into cos wx. But in place of x we have 0. So cos wx will be cos 0. So cos 0 is what? 1. So 1 into w will be w. So that way we have to write. Next what will happen? Next we have to solve this inside bracket. So there will be minus and minus. So minus minus plus. Minus into minus plus. So plus. So first factor we have to write square root of 2 by pi into what? W by 1 plus w square. So this will be our answer, or this will be the Fourier sine transform of the function e to the power minus x. So in this way we can solve various problems and apply Fourier sine transform.